Hey, in this new series I want to take a look at the topic of AI in games and how to concretely implement it in Unity. Instead of giving you a formal introduction into some concepts of video game AI, and there are great resources on that on YouTube, I want to kick off the series by jumping straight into a hands-on example. I will show you how to recreate the False Knight, which is the first boss from Hollow Knight. For implementing the AI, we are going to use behavior trees, which is one of the industry standards for representing complex lifelike behaviors. I will explain the fundamentals of behavior trees as we move along. Unlike Unreal, Unity doesn't have a built-in implementation of behavior trees, unfortunately, but luckily there is a great plugin Behavior Designer available on the Asset Store. It's not free, but it's one of those assets that's definitely worth the money if you want a clean way to build AI behaviors for your game. I have built a basic 2D platformer setup in Unity, including a character controller with the Knight's basic moveset and attack, as well as some basic architecture for enemies, combat, visual effects, and so on. I didn't spend much time trying to imitate the Knight's mechanics accurately, since the focus will be on the boss. If you're interested in how I implemented this part as well, let me know in the comments, and I will consider making a series on advanced 2D platformer stuff. I used ripped sprites from the original game, which you can download on spritosresource.com, for instance. Obviously, these are for educational purposes only, and you shouldn't use them for your game if you intend to publish it. Hollow Knight uses frame-by-frame sprite sheet animation for pretty much everything in the game. I invested some time in getting the individual parts from the False Knight sprite sheet and created the individual animations in Unity. I also created the animation controller, which consists mostly of triggers that play certain animations in sequence, like for instance the jump, which consists of 3 parts: the anticipation, the actual jump, and the landing. If you want to follow along, you can find a link in the description to this Unity project where all of the basics are set up. Let's start by looking at the False Knight boss fight and try to analyze the different patterns and stages of the boss. So it all starts with the boss intro. The False Knight drops from the top of the screen. Then starts stage 1. The boss is altering between an idle loop that takes a few seconds and some randomly selected attack move. In this case, it's a basic jump, which allows the player to switch sides. The next move is a more elaborate jump with a hammer attack on landing. After the boss took 13 hits, if I counted correctly, it retreats into this rolled up pose, and the maggot that is the actual False Knight spawns just to be smashed by the player. After 8 more hits, the boss recovers and goes back into fighting mode. Due to the healing system in Hollow Knight, almost all of their bosses use this pattern, often alternating fight and recovery phase. Okay, let's continue. In stage 2, there is immediately this new attack move, which is this rampaging, repeated hammer smash in both directions, accompanied by a rain of falling rocks. Additionally, there are all of the previous moves as well, and again after 13 hits, recovery phase with 8 hits on the maggot. Stage 3 features a new move, which is a hammer smash followed by this accelerating shockwave, as well as a few falling rocks. All the other moves are now followed by these falling rocks as well. Okay, recovery and final stage 4. Here we've got 2 more attack moves, and finally the crushing blow from the False Knight, sending it downstairs and waiting for the final 8 hits on the maggot until it's finally complete. So obviously it would take a few more videos to completely understand the distribution of the different moves per stage and so on, but I think what we've seen is good enough to reproduce it to a pretty good degree. Alright, now that we know every little detail on how the False Knight acts, let's try to implement that ourselves. Let's start with the base prefab, which at this point is just a sprite and an animator component. First, we'll create a parent object to this sprite, because it's always a good idea to group sprites or 3D models or whatever the visuals into a sub-object, just in case we want to change it later on. Then on the root object, put on a box collider 2D and a rigid body 2D. as well as a destructible component, which tells the actor to be able to receive hits from the combat system. And here we can set the hit type to color and the hit material to sprite white, which is this flashy effect whenever the enemy gets hit. The health, I think we'll set to 30 or 40 for now, and the rest of it should be fine. Now let's also set the box collider to something that makes kind of sense. Now finally, let's add a behavior tree component. This will allow us to create a behavior tree for that specific actor. So go to open, and the behavior designer editor will open, giving us a blank graph. Hit spacebar and start typing to search for nodes. Let's add a repeater first. And this will automatically connect it to the root entry node. The repeater requires a child node. So let's add a sequence node. This node basically executes all of its children in order. So in order to complete our first most basic tree, let's add a debug log node where we can set a text, hello world. And after that, a wait node, which is just waits for a given time. Set this to 2 and connect these two to the sequence. By the way, the execution flow in behavior trees is always top to bottom and left to right. If we now execute this, we expect it to log hello world every 2 seconds and repeat forever. Oh, actually, on the repeater, we have to select repeat forever because for some reason this is not checked by default. Yeah, if we look in the console, it logs hello world every 2 seconds, so that's fine. Now, instead of the console log, we want to have an actual first move. Let's do the basic jump move first. For the jump, we want to apply some upward force to our boss's rigid body, while also setting a trigger on the animator. Then on landing, we want some effects like particles, sounds, camera shake. Behavior Designer supports many Unity functions as nodes, so technically we could do most of this stuff without writing code. However, I really like to keep our trees clean, and using nodes for every single operation will quickly result in a confusing mess and would turn it into more of a visual scripting tool than a tool for creating AI behavior. Luckily, we can create our own little nodes, or tasks as they are called, which is as simple as creating a new class and deriving it from one of Behavior Designer's base classes, most importantly action or conditional. Aside from some special cases, both have very similar functionality, but as a rule of thumb, we can say actions are changing the state of our actor, while conditionals are only querying something. Since we will often want to access the same components of our actors, I've also created the 2 base classes, enemy action and enemy conditional, which we'll actually derive from. This is just for convenience, and they really do nothing other than fetching some common components and assigning them as member variables. Now back to our intent of creating a jump. So jump is definitely an action, so we derive from enemy action. Then we create a few fields like jump forces and jump time and build up time, which will determine when the jump starts and when the jump ends, since we don't want some elaborate landing detection for now. Fields are visible in the inspector of the node in the designer, so it's very similar to Unity's mono behaviors. Next, we are implementing the onStart and the onUpdate method. Make sure to override the methods inherited from our action class, not confuse it with Unity's lifecycle methods, which shouldn't be available here anyway, since this isn't a mono behavior. OnStart is called once when the node is executed in the behavior tree. OnUpdate is called every single frame after the node has been executed. You might ask yourself, how could the node run more than one frame? And this is where the task status comes in, which is the return type of our onUpdate method. If we take a closer look, task status is an enum with the states success, failure, running, and inactive. Success and failure affects the execution flow of the behavior tree. More on that later, while running means we want to stick around on our current task. That's when the update method will be called multiple frames, precisely as long as a status of running is returned. An example would be a task move to target, which in every frame will check if the actor has reached the target and otherwise will return running. That way the next node in the tree after move to target can safely assume that the actor has actually reached the target before continuing with something else. So now that we know all the details of tasks, let's finally write our jump task. In the start, we want to apply our jump force once. We also want to wait for jump time seconds and after that tell the actor that it has landed. Of course, a more general resolution would be to physically detect when the actor has landed, for instance with a raycast, but I think for our use case the timing-based approach is enough. By the way, for the wait I'm using doVirtual delayed call, which is a convenient method from the doTween tweening library, which executes a given function or lambda after the delay, and it's a little more convenient than coroutines. Finally, in the onUpdate, we will return success if the actor has landed and running otherwise. Finally, we implement the onEnd method, which is called when the task ends, and it can usually be used for cleaning up certain things like resetting variables. So in our case, we reset the has landed variable, and we also kill the tweens which could still be active if the jump has been cancelled in some way. Back in Behavior Designer, our custom jump task should now be listed and we can add it to our tree. Now let's set the variables, the jump times and the forces, and also let's set the animation trigger name. So if we take a look at our animator, that is attached to the false knight sprite. There are quite a few nodes, but for our jump it is interesting to look at this part, and in order to trigger these 3 nodes there is one trigger that is called jump, so we want to set that in our behavior tree. Alright, let's run our game and test if our jump move works so far. And as we can see here, the jump is still pretty floaty, which the issue is that we haven't adjusted the gravity scale. So if we set the gravity scale on our false knight's rigid body to 3, it should work. And yes, that looks way better. But actually one minor detail that is still missing is the boss's orientation. So we want to add a new custom task face player, which just sets the X scale of the enemy to a positive or a negative value based on whether it is to the left or to the right of the player. Finally, we want to include this between the jump and the wait interval, and let's quickly check if it works. Okay, perfect. So on landing, the boss is facing the player, which I think should be like it is in the original. Oh, and we still have a problem with the rotation, so we want to constrain the rotation on the rigid body, of course. We also noticed that the enemy, the boss, can actually land on our player character, which of course we don't want as well. So we don't really want collisions appearing between the player and the enemy directly, but we still want, of course, that the player is hurt if it touches the enemy. So let's add another collider object, which we call hazard collider, and we have this neat little component which is just called hazard. So in order to avoid collisions between the enemy and the player, let's set this to the collision layer enemy, which in our collision matrix we can see that collisions between these 2 layers are disabled. And now it looks much better. Now that we have seen how to implement a basic move, let's do the same for another little more complex move, this hammer smash, including the shockwave and the falling rocks. So the shockwave is essentially just a projectile that is accelerating horizontally. I've got some very basic projectile architecture in my setup project. Again, I won't go into detail, but if you're interested, let me know. So let's first assemble the shockwave prefab, which just uses this single sprite. I actually couldn't find a sprite sheet for the shockwave from the original game, but it should do. And let's add a polygon collider to closely resemble the visuals as well as our accelerating projectile component, where we can also set some effects, some particle effects for impact. Then we'll create another custom task, which we'll just call shoot, so we can maybe reuse it for all kinds of scenarios where the enemy shoots a projectile. Aside from the projectile, there is also a weapon data type, which holds a reference to the used projectile prefab, a transform to know where to spawn the projectile, and a horizontal and vertical shoot force. So in our task, we create a list of weapons just in case the enemy shoots different projectiles at once. Then for each weapon we instantiate the projectile prefab and set the force, which is the weapon force, and additionally we also multiply the x value by the enemy's x scale, which in our case is equal to the facing direction. So besides the shockwave projectile, there are these falling rocks, which are spawned at a random X position at the top of the boss arena. They're used by various different boss moves actually, and also the amount of falling rocks vary. So we want that to be definable as a parameter. So of course we'll create another custom task for spawning the rocks, but first we're gonna need a prefab. Since we've just done it, let's again use the projectile system for it. So the rock has a circle collider and a rigid body with default gravity, and a projectile component, in that case the default projectile, which just takes an initial force and otherwise is just affected by regular gravity. Additionally to the rock prefab, we also need to define the area where those rocks are allowed to be spawned. We'll just create an empty object with a box collider because it's convenient to edit the bounds, so the horizontal extents will determine the bounds of the rock spawner. Now let's create another custom task called spawn falling rocks, which of course is again an enemy action. Here we want a reference to our area collider, one to the rock prefab, a spawn count and an interval between the rocks. Then in the onUpdate, we're just creating a doTween sequence, which allows us to queue several function calls with an interval in between. And finally, our spawn rock function is as simple as getting a random X position within our collider's bounds, instantiating the rock object and giving it a force of 0 because we just want gravity to take care of it. Okay, now that we've finished our two custom tasks, let's add the nodes to our behavior tree to implement the second move of our boss. So just like we did for the jump, we want some tasks to be executed in order. So we connect them via a sequence as the parent. So we want to add our shoot and afterwards a wait interval again. And also the first part of this move is playing the attack animation. We didn't include setting the animation trigger in our task now, but actually there is a specific node for setting an animation trigger, which is just called set trigger, so we can use them to be a little more flexible in that case. And we want to set two triggers actually in that case. The first one is start attack, which is triggering the attack anticipation phase. And then after the configurable anticipation time, we want to trigger the actual attack, which is then performing the hammer smash. Also, we've added another phase player node in the beginning and included a few more wait intervals so the timing is perfect. And then instead of using the jump, let's connect the repeater to our new smash move. Okay, so one last thing is we want another hazard collider to be activated during the hammer smash because that would extend the boss's damage area basically. So we want to tie that strongly to the animation itself. So let's look into animator events. Inside Unity's animation editor, we can set these little events on each frame. Then we can define a function that should be called on that frame. And as you can see here, they are already part of the animation, but can't find the function. And this is because we need to attach a script that actually contains these functions. And I already prepared such a script, which is called attack animator events, which just contains two functions, on attack start and on attack end. So if we put this on our sprite, where the animator component is also on, we should then be able to select these functions as animation events. So let's add another collider, attack collider, with another hazard component. And let's disable this by default because it is then toggled inside the attack animator events script. And finally assign the fields and we should be good to go. All right, let's start the game again. Okay, so the attack move seems to work. However, we don't get any shockwave or falling rocks. So let's see in our behavior tree. And yeah, of course, I messed up the shoot node. This should actually contain a reference to the shockwave projectile. And I have forgotten to add the spawn falling rocks node altogether. So let's include that as well. And now it seems to work better. However, the falling rocks are not disappearing when hitting the ground. So yeah, let's take a closer look. And of course the collider needs to be a trigger because in the projectile class we listen to the on trigger enter and not the on collision enter. Also for a final detail, let's add a little smoke particle trail to improve the notion of the falling rocks. And let's test again. And now this looks way better. Now that we have two separate sequences, we need some way to connect these two. In fact, what we want is after each repetition, we want to randomly select one of these sequences. So besides the sequence, there is a selector task which executes its children only until the first child returns success as a task status. So think of it as a logical OR instead of a logical AND for sequences. So that is definitely what we need here. But since we don't always want to execute the first child, we'll use the random selector. And if we test this now, we can kind of see that our two moves are randomly selected. All right, before we continue implementing the remaining moves, let's tackle another interesting part of the boss's behavior. Switching between stages and the recovery stage where the boss gives the player this time to relax. So the recovery phase should be triggered as soon as the boss took a certain number of hits, or more generally the health reached a certain threshold. So before we do anything else, let's create another custom task. This time our first conditional, because we want to check the current health and don't act on anything. Okay, so as soon as this event happens, the boss should abort whatever it was just doing and enter another branch in the behavior tree. There are generally two kinds of ways to express something like this in the behavior tree: interrupts and what we are going to use, conditional aborts. So conditional aborts are a way of stating that an ongoing task can be interrupted as soon as a certain conditional changes its state. So generally that means that the state changes from failure to success. The best way to understand this is probably to just see it in action. So first we need to restructure our tree a little bit. So this repeater and all of its children is our core fight loop basically. Now as a parent of that, we want to add another selector. The fight loop will always be the rightmost child of that. And on the left side, let's add a sequence as a sibling to our fight loop. And as a child of that, we'll add our conditional is health under. Now the key is to set the abort type of this sequence to lower priority. This means that lower priority tasks, which are all tasks to the right of this node, are aborted as soon as the first child conditional returns success. So let's go through the entire tree to understand what this actually means. So at the top level, we have a selector which executes all children until one of them returns success. So at the very top, let's actually add another repeater just to make sure that the tree doesn't completely end when something goes wrong. So it starts with this sequence which has the conditional is health under. At the beginning, the boss's health is not under this threshold, so this will return failure, meaning we execute the next child in the root selector, which already is our core fight loop that periodically selects and performs a random attack move. Now usually as soon as we enter this repeater, we should be locked inside. There is no way out since the repeater is set to loop forever and only fails if all children fail, which currently doesn't happen. However, because we set the abort type of this to lower priority, every frame this conditional is re-evaluated, and the moment it succeeds, we continue on this branch of the tree. I hope this makes a little sense. Conditional aborts can be a little tricky at first, but luckily Behavior Designer has a good runtime visualization, which we'll look in a second. So if we run this now, the current active task is the repeater. Now let's hit the enemy a few times. And as soon as this conditional is fulfilled, yes, now we can see the execution branch has moved to here, although we technically would be stuck in this repeater loop forever. Alright, so now that we have escaped from the core loop, as soon as the boss took a certain amount of damage, let's actually implement the recovery behavior. So first the boss is knocked back. We will use our jump task for that, give it some negative horizontal force to be pushed in the opposite direction of the player, and assign the correct animation trigger. After that, we want to spawn the maggot, which lives inside the false knight's armor and is exposed in each recovery stage. Again, we want to prepare the prefab for it. And then again, we'll create another custom task, spawn maggot, which instantiates this prefab and in the onUpdate checks whether the maggot is still alive. In that case, it returns running, and as soon as it's killed, it returns success. Then we need another custom task that resets our health, so just a basic set health. And let's do another one that very shortly freezes time in order to get this strong impact feedback, which is often used in Hollow Knight. Finally, let's add these tasks to our behavior tree and let's test. Alright, we still have some problems with the maggot, so let's see. Okay, so again, I've forgotten to set the isTrigger on the maggot's collider. Then also on the maggot's sprite, we should set the sorting layer to something higher than 0 in order to appear in front of the boss. And finally, when instantiating the maggot, we should reset the local position to 0 just to make sure that it's properly parented. Alright, now it seems to be fine. So if we hit this 8 times, yes, it should again trigger the recovery and the boss gets back to its fighting stage. Alright, now we have our fighting phase of selecting random moves. We have our recovery phase of spawning the maggot and waiting for it to be killed. Now all that's left is to implement the remaining attack moves and also have some way of deciding which moves are possible in which stages. So let's start with the remaining moves. So for that we don't really need any new custom tasks because luckily we have written them in a way that they can easily be reused with different parameters. So it's just a different arrangement of the nodes in the behavior tree. So the jump attack, for instance, is just a combination of a jump followed by some falling rocks and of course using the respective animation trigger. And the rampage attack is a series of setting some animation triggers, an initial spawn of falling rocks. We'll use a nested repeater with a fixed iteration count of 8 for that. And I've created one more custom task here to manually turn around the enemy, which is just multiplying the scale with -1 basically. Alright, let's test one more time to see the new moves in action. Here we've got the jump, we've got the rampage. Yeah, it all looks pretty decent, I would say. Now in most cases, a boss will tend to get stronger as the fight progresses. That means instead of randomly selecting out of the entire set of attack moves, we want to define for each stage which moves to choose from. So first of all, let's introduce a Blackboard variable. So Blackboard variables are essentially shared variables that can be accessed across the behavior tree in order to exchange some data between different nodes. So let's create a shared integer, current stage. Now let's create one simple custom task, go to next stage. This one is taking a shared int instead of a regular int as a parameter, which, as you'll see in a second, means that we can use it as a Blackboard variable. And this is basically just incrementing the current stage by 1 and returning success. Now if we add this node, which we'll do of course at the end of our recovery, and here instead of inputting an actual integer value, we can click on this button, which allows us to choose any of our Blackboard variables. So for now we just have the current stage, and now later in some other tasks we can use this Blackboard variable in order to query the current stage. Okay, now one way to have this stage-based selection would of course be to have some simple separation based on the current stage, and then in each branch include the possible moves. However, since more often than not the boss will use the same moves over and over in multiple different stages, we would have to copy and paste these subtrees over and over, so surely there's a better solution. And what I've come up with is to implement a custom composite type, which are these tasks that can have a list of children like our sequence and our selector. So instead of a random selector, we'd like to have a stage-based selector, which works exactly like the random selector, but only considers certain children in certain stages. Let's implement this. As a basis, we'll just use the code from a random selector. It's not that complicated. As we can see here, the interesting part for us is in the onAwake, where a list of child indices is created by going through all of the children and adding their index. Now instead of using all indices, we want to specify a list of indices for each stage. So to represent this, we'd need a list of integers, but since that's annoying to use in the inspector, let's just use a list of strings and expect each string to be a list of comma-separated integers. Then here we can just get the string based on the current stage, parse it, and assign it to our child indices list. And we also need to move this to the onStart method because we want to select a new list each time this node is called, which is whenever the current stage has been changed. Now in our behavior tree, we just need to replace the random selector with our custom stage-based selector, and we'll need to enter some values for our indices lists. So let's say in our first stage, we only want the first child to be executed, which is our jump task. Then in stage 2, we want to have move 0 and 2. And finally, in the third stage, we want to have all of them. All right, let's do a basic test to see if it works. So in the first stage, there should only be the jump move. Yes. Then in stage 2, there should be the jump move as well as the smash move. That looks good as well. And finally, in the final stage 3, there should be all of them. And this looks good as well. Perfect. Now to finish things off, let's take a look at the boss's entrance and of course the death. So for the entrance, it's basically just a jump move that starts mid-air at the top of the screen. So to keep things simple, let's just place our boss at the target location slightly above the boss arena. And in the behavior tree, we'll branch off before our main repeater loop starts. So introduce a new sequence that executes a bunch of initialization tasks. So let's face to the player, then execute the jump and set the jump animation trigger. And for simplicity, let's also add a task here, which is just displaying the boss name in the UI. Finally, let's add one more branch that detects the boss's death here as a sibling to our fight phase and our recovery phase, just in between. So in our case, the boss death happens before we would enter the fourth stage. So after the maggot has been destroyed, and the current stage here is greater or equal to 3. And let's add one last custom task, destroy boss, which will just play 2 particle effects, the build-up smoke and this final explosion, and after that will just destroy itself. Alright, let's add this to our behavior tree, and let's add an idle node just to be sure. And then I think we're done. Let's do our final playthrough. Alright, so that was our recreation of the False Knight boss fight. I obviously made some compromises now, especially in the final stage, where there would actually be this collapsing ground, but actually I didn't have all of the assets to properly recreate this, so I just went for destroying the boss right away. Also, of course, I did not put too much effort in recreating all the particle effects perfectly and so on, but my goal for this video was to show you that behavior trees can be a really nice, easy and especially clean way to implement seemingly complicated AI behaviors. If you like this video, there will definitely be more of that kind in the future. So I hope to see you next time. Until then, have fun creating. Bye.